Thank you, Kelly. I'm Chowdhury Rafatul Kabir. Good afternoon, everyone. I have completed my bachelor and master's from Chowdhury University of Science and Technology, Bangladesh. And now I'll be sharing with you my master's project, which is named Climate Sensitivity of Hydnocarpus kurzii Radial Growth at the Rema-Kalenga Wildlife Sanctuary, Bangladesh. So tropical forest plays a very vital role and significant role as global carbon sinks, and they play as a biodiversity hotspot. We all know that, and their importance in our world. However, we also know that gradually our climate has been changing, and it's affecting our environment and also in the tropical forest, and it may limit the tree growth, and the species can react negatively because of climate change. So dendrochronology is an interesting technique that we use to study tree rings, and tree rings that store the information about any climatic influence on the growth of their trees. So study of tree ring can provide us information about climate and tree growth and how a species reacted, and how can we also can project how they will react in future climate change events. So there was a gap to understand species-specific tree response in the northeastern part of South Asian part of the world, and specifically in our country, the species-specific response is not well understood. So I wanted to shed more light on this, and I have selected a species, Hydnocarpus kurzii, which has a medicinal importance and also have some economical values. Moving forward, we had some research questions. These are the research questions that do the time series of Hydnocarpus kurzii cross-date each other and contain common environmental signals. And how do the local climate condition affect the radial growth of Hydnocarpus kurzii at the Rema-Kalenga Wildlife Sanctuary, which is our study site? Is the radial growth of Hydnocarpus kurzii influenced by regional climate and large-scale climate drivers? And has the sensitivity of Hydnocarpus kurzii increased in the recent decades? So these are the questions we try to answer in our investigation. So here is our study area, which is the Rema-Kalenga Wildlife Sanctuary, which is situated in the northeastern part of Bangladesh. We selected our species Hydnocarpus kurzii. We collected sample from 4 to 5 trees. From each trees, we collected 2 cores. We obviously selected healthy trees when we core from the trees, and we used Hagel's increment 5.15 millimeter Hagel's increment borer. So here is the climate of our study site. We can see that the annual mean annual climate trend for maximum temperature, minimum temperature, and the mean average temperature is rising, have an upward trend. And here is the climate. Here is the average precipitation and average temperature from our nearest climate station. Here we have divided the climate of our study site into 2 sub-periods, one from 1950 to 1985 and another one from 1986 to 2020. And we also divided, we also check the season-wise the response, and pre-monsoon is from February, March, and April. Monsoon, March, June, July, August. Post-monsoon, September, October. And dry season, we checked November, December, January, February, and April. And here, what we did that we wanted to check if there any significant trend for climate in the recent decades, and we can see that for maximum and mean temperature, we could see monsoon and post-monsoon showed significant trend. And For the methodology part, we used simple dendrochronological technique and collected a sample from our study site. We used Hagel's increment borer and collected 2 cores from each trees, and then the core were air dried to avoid fungal infection. Then we came back to our laboratory, and there we sended from maintaining proper grid size, and after the proper sending, we used scanning, and then we moved for ring detection part. We used C-Dendro software and kurzii for ring detection purpose, and cross dating was performed using TSAP Windows software. And after a successful cross dating, we used a DPLR package from R to build a standard ring width index chronology. So in the statistical analysis, for the beginning part, we used a DPLR package and QuickLim package from R Studio, and a simple Pearson correlation we checked. We checked the moving correlation in a 30 years window. And for the spatial correlation part, we used KNMI Climate Explorer. Here we can see we have built the standard ring width index chronology for Hydnocarpus kurzii in any tropical forest of Southeast Asia, or any tropical forest actually. And the individual time series were synchronized well after our cross dating. And mean EPS value, we can see that mark and mean EPS value was above the threshold mark 0.85. And here are the statistics of our standard ring width index chronology. We can see that express population signal, mean sensitivity, signal to noise ratio, and R-bar efficient all are in a good numbers, so that it confirms the robustness of the chronology, and we can move on for further climate growth analysis. In the climate growth relationship, we used simple Pearson correlation coefficient, and we had a 19 years window from previous year May to current year November. We wanted to check if there are any lag effect. That's why we counted previous year's effect. So we have found that pre-monsoon and dry season affecting tree radial growth negatively, and post-monsoon maximum temperature and post-monsoon mean temperature affecting tree radial growth also negatively. So there are also some prior years effect on current year growth, June, and minimum temperature July and mean temperature June affecting tree growth negatively. We also checked climate sensitivity of Hydnocarpus kurzii. February, March, June, and August maximum temperature showed consistent negative effect on tree radial growth on the recent decades. And for mean temperature, February mean temperature showed sheer negative impact on tree radial growth as well. We can see that here that the significant correlation has been changing, and in the past it was January and March and also November for maximum and mean temperature, and in the recent decades it's showing that February, March, and August having a real negative impact on the radial growth. For mean temperature, we can see February affecting in the recent decades more impactfully, and in the past it was November, and in the recent decades it had been shifted to February. And for precipitation, we can see that March having a positive impact on tree radial growth, and in the past it was January that for the last few decades it was consistent, but in the recent few decades it lost its consistency. After that, we checked the regression analysis, and for the regression analysis part, we divided the periods into two sub-periods called from 1961 to 1991 and 1992 to 2022. Red marked trend line shows that 1992 2022, and blue color trend line shows 1961 to 1991. We decided to check from 1961 to 2022 because that our EPS value was higher. Though we had our chronology from 1937 to 2022, but our EPS value was higher in the period from the period 1961 above the threshold mark. That's why we wanted to check this, and we have found that maximum temperature March, mean temperature February, mean temperature average temperature February, and average temperature March, average temperature pre-monsoons, all are showing significant negative relation in the recent decades than the past. We wanted to check the regional climate datasets relation to our study site and our ring width index chronology, and we have found that it had some relation, and those were negative relation to the regional dataset. So maximum temperature March, maximum temperature September, and minimum temperature March all had shown negative impact on tree radial growth. Only September precipitation showed significant positive impact on tree radial growth. We also checked the effect of sea surface temperature on our study site and our ring width index chronology, and we have found that it had some effect on the growth of our trees. And March sea surface temperature and dry season sea surface temperature all showed significant negative impact on tree radial growth. So here are the results that we first knew that our species had some potential and showed them distinct growth ring boundaries from the study of Dr. Mahmoud Islam. We identified these species and may show the good result on dating and cross dating. Then we checked the whole we had done the whole process and found that the individual ring width theories cross dated well, and we could build a standard ring width index chronology successfully. Though I had mentioned it earlier that our chronology was built from 1937 to 2022, but the mean EPS value was higher above the threshold mark from 1961 to 2022. That's why we checked the relation between climate variables from 1961. Also, our chronology contained common environmental signals that the statistics ensure, and the temperature were significantly correlated with our ring width index chronology. Pre-monsoon temperature and dry season temperature had strong negative influence on tree radial growth. We saw from our previous results. And there is a take-home message that pre-monsoon and dry season temperature are growth limiting factor for Hydnocarpus kurzii in the Rema-Kalenga Wildlife Sanctuary. This season may limit limiting the growth of this species, and also we have found the large-scale climate influence, which may modulate our local climate and have influence on a overall basis. And we have got the appearance of teleconnections in the relation to climate growth, and the short-term lag effect, which is the prior year effect to current year growth. So Hydnocarpus kurzii growth has become more climate sensitive in the recent decades, and the radial growth, it is hypothesized by us that Hydnocarpus kurzii radial growth will be declined as temperature continue to rise, and if it reacts like this and continue to react like this, we may find in a position that decreased radial growth may limit the forest ability to preserve carbon, and we may face the consequences, and this study may be may may help us understand the future climate, the response of future climate events. So I want to thank my supervisor and co-supervisor, Dr. Mizanur Rahman and Dr. Mahmoud Islam, for constant their supervision and direction. And this was funded by Sustainable Forest and Livelihood Project. And I want to thank my university laboratory space for allowing me to do my my research. So thank you, everyone. This were my presentation about my recent work.
Congratulations, Rafatul, Kabir. Very interesting your presentation. We can see in your graphic, in your picture, when you collect your sample, these species that you are working, we can see that the color of this species, about the rainforest, is the color is very, very clear. So I think that when you are working, making your measurements was very, very hard.
Yeah.
Yeah, because I can see the terrain sometimes it is very transparent.
Yeah.
I would work
Lily, I have a question.
that you face. Many, maybe any participant want to make a question? You are welcome, please.
Yes.
Okay,
Lily, I have a question.
You're welcome.
Okay, Rafatul, you make a very good presentation. I have a question. You have shown in your results that carbon sequestration is decreasing with the increase of temperature. In your country, have another species shown the same result, meaning to say another species, coniferous species or hardwood species?
Sorry.
No,
sorry. I have just hypothesized in my conclusion that if we go in that process continuously, that the radial growth is responding to climate change or extreme events negatively. So in future there will be small ring width boundaries, and small ring width boundaries mean that in the way they preserve the carbon, it will be decreased. Okay. So I think
actually I want to ask, some other species have shown the same result as you have mentioned in your presentation, that as the temperature increased, you have shown that your growth, radial growth, has been decreased. I want to know, another species has shown the same results?
Yes, I've been working with another species, which is Melina arborea. So this species also,
it's a hardwood species.
Yeah, this is a hardwood species, and
so you people have also received the same situation with the coniferous species in your country?
Sorry, I haven't worked with any coniferous species, so it's a question that we can.
Actually, we are also working on this dendrochronology, and we have seen in most of our study site, with the increase of temperature, there is an increase in radial growth of at least coniferous species. So I think there will be the same situation in case of hardwood species. Another thing we are working on that, we have seen that with the increase of temperature, there is a decrease in, you can say, density trend.
Okay.
So we can say that in most of the study site, we have seen that with the increase of temperature, growth has increased, but the density pattern has decreased. I mean to say the wood quality is decreasing. We have got a result in Pakistan.
Okay, so I think it has to do with the environment. I think it
I
has
think
an effect.
there is no big difference between the climate of Pakistan as well as Bangladesh.
Yeah, I guess so. But we have studied.
Hello, parece the microphone. Okay,
Rafatul, I cannot hear your voice.
maybe the internet is affecting to Rafatul, Kabir.
Okay, Kali, thank you so much.
Maybe your internet, Rafatul Kabir, was interfered, not?
Yeah, a bit.
Yeah,
Can you hear me now?
yeah, okay. Talvin, did you finish? Because the
Thank you so much.
internet.
Thank you so much. Thank you so much.
Okay, thank you so much too. Maybe we have another question. You are welcome for this interesting topic. So we will continue it with our last presentation.